So one of the characteristics we're going to talk about today is called the zero of a function. And the zero of a function plays a pretty important role in a quadratic function. We're going to learn, further as we go down the road. So the zero of a function, when I'm asking you to get the zero of a function, or some problem is asking you for the zero of a function, they're asking you for the x value that makes the function equal 0. In other words, makes the y equal 0. What's the x value that when you put it into the function, it will give you a y value of 0? So the zero of a function always has a y value of 0. To find it on a graph, you're going to look for where the x-intercept. Now, we've mostly talked about y-intercepts with linear equations. And remember, a y-intercept is where the line crosses the y-axis. Well, if a y-intercept is where the line crosses a y-axis, what do you suppose an x-intercept is then? Where it crosses the x-axis. Well, now we don't have a line, but instead we have a what? What's our shape of our graph for quadratic?
A U.
It's a U. So we're actually going to look for where does the U cross the x-axis. So we're going to look for the x-intercept of the function. Well, here's the deal. There can be, for a function, a quadratic function, there can be 1, 0. There can only be one spot where that U is going to cross the x-axis. There might be 2 places, or there may not be any. So does anybody right now think they could picture a time when a U-shaped graph would only touch the x-axis, would only cross the x-axis at one spot? When would that be? Okay, but if it's at 0, -1, it's crossing at 0, -1. Could it cross somewhere else further down the road, like, or remember, not 0, -1, because it's got to have a y value of 0. So maybe you meant -1, 0.
Yeah.
Okay. So if it's crossing at -1, 0 on the x-axis, could it not be crossing somewhere else further to the left or further to the right? Haley, what do you think? When the vertex is on the x-axis. When the parabola is sitting on the x-axis opening up, when the vertex is right on the x-axis, then there's no other place it can cross it at, because where does it make its turn? It makes its turn at the vertex. There's no other point that is symmetric to that. So we could have a parabola opening down with its vertex on the x-axis. So in fact, let's try and make a little picture here of what that would look like. If there's only 1, 0, we could say we have the vertex on the x-axis and it's opening up. Or we could say it is vertex on the x-axis and it's opening down. There's 2 different parabolas there. They each only have one x-intercept. They each only touch the x-axis in one spot. But when there's 2 zeros, now we're talking about we have a parabola that's crossing in 2 different spots here. There's 2 different places it's crossing. The vertex is not sitting on the x-axis. It's somewhere else in the coordinate plane. When there are no zeros, anybody want to predict what's happening when there are no zeros?
Straight line.
A straight line? No, it's still quadratic.
It doesn't touch.
Can't touch. So maybe we could have a parabola that's up here opening like this. It's up there.
Or couldn't you just have it like on the top line and it just doesn't touch?
Or like here, you mean?
Yeah.
Yeah, it could be there. It could be here. It could be here. It's, in other words, if it's below the x-axis and opening down, is it ever going to touch the x-axis? No. If it's above the x-axis and opening up, is it ever going to touch the x-axis?
No.
No. So those are the times when there would be no zero. So let's turn in our books to page 531. And we're going to do the check it out problems at the bottom of the page where it says, find the zeros of each quadratic function from its graph and check your answer. Okay. Now, if you look above at example 1, there are some pictures of those situations we just talked about. In example 1a, how many zeros are there for that one?
2.
2. It's crossing the x-axis in 2 places. What are the zeros?
2, 0, and -1, 0.
Yeah, -1, 0, and 2, 0. But when we talk about the zeros, we get to just name the x value. So what's the x value of each of those? 2 and -1. So we say the zeros for that one are 2 and -1. How about example 1b? How many zeros are there? 1. Look at there, we got the vertex sitting on the x-axis. What's the zero? What's that 1, 0 for this function? X equals what?
3.
X equals 1. It's
I don't get this.
touching the x-axis at 1. Look at the vertex in example 1b. We're looking at the example problem, not the check it out.
Oh, okay.
Example
Never mind.
1b.
Never
We're going to do the check it out because we're looking at example 1b. So the 0 in 1b is what again?
1.
1. What's the case in example 1c?
None.
There are no zeros, are there? It is not crossing the x-axis, so we would say there are no zeros. Okay, now let's do 1a together. What do you think?
It's going to be none.
Okay, because the parabola does not touch or cross the x-axis, therefore there are no zeros.
Is that all we're doing?
That's one of the things we do. Okay, now it tells you to do a check problem, but I'm not going to make you do the check problem, okay?
Today or just right now?
In even in these directions, it says check your answer. In the homework, I'm not going to make you either, okay? Okay. 1b. What do
It's
you
going to
think?
be 3.
1, 0. And what is it?
3.
3. Okay, so the parabola is touching the x-axis at
0,
3, 0.
0. Just
Yeah,
kidding.
at ordered pair 3, 0. That's its x-intercept. So it appears there is 1, 0,
And it's 3.
and it is 3, yeah. Okay, it says here that we're going to do a check problem. We will do this one, just a check problem here, just to show you what should happen. What do you think should happen if we put 3 in for x?
It should.
It should be not squared.
Okay, well, if that's what's going to happen. Well, let's see what happens then. Let's put it in.
Well,
3 is going in for x. Yeah, we better get 0
Oh, I was counting for.
because we're going to get y. And what's the y value of that x-intercept? It's 0. So we better get 0 for y when we're all done here. So 3 squared is
9.
9. And you take away 18, add 9.
You get 0.
What's 9 take away 18?
-9.
Negative 9.
Plus that is 0.
What happens when you add opposites? You get 0. So y equals 0. So if it truly is a 0, remember, a 0 of the quadratic function is what's the x value that will make y be 0. And that's what we just found. We found the x value that will make y equal 0. Do you think there are any others for this one? No. It's only touching the x-axis at that one spot. There's no other spot that it is. Okay, so we're going to kind of summarize here. Here's what we can count on. When there's only 1 0, it's going to be the x value of what?
Where?
Hey, where's it going to touch? What did we decide? It's going to touch the x-axis, but if it's only touching the x-axis in one spot, what's another name for that point? vertex, yeah. So when there's only one zero, it's going to be the x value of the vertex. So if they tell you what the vertex is and they say there's only one zero, you get to say, oh, well then that zero is, the x value of that point, of that vertex. When there are two zeros, or in other words, I say to you there are two zeros for this parabola, you don't get to see the graph, you should be able to say to yourself, when Mrs. Legrand says there are two zeros for this function, what should happen with the parabola crossing the x-axis? It better touch in two different places, because there are two zeros. And of course we know that when there are no zeros, it
Doesn't touch at all.
doesn't touch at all. Okay, so anything still unclear here?
No, that makes sense.
Okay. Now what we're going to do is we're going to learn, we're going to talk about, when we've already talked about this before, if we have a there's an imaginary line that actually runs through every quadratic function's graph, that parabola. Does anybody remember what it's called? That divides it into two symmetrical halves? Axis of symmetry. So it's going to be a vertical line.
Good afternoon. Let me give you an update on activities for the afternoon because of the weather.
Back to work here. Okay, so with the vertical line that's imaginary, that path that goes through any parabola and divides it into two symmetrical halves is called the axis of symmetry. What do you suppose it always has to pass through? The middle. And what's the middle called of a parabola? The vertex. Yeah, it's called the vertex. So it always has to pass.
One more update of practices. Practices will be held after school today as scheduled, but rural students can choose to stay or leave practice at that time. Thank you.
Okay, so it always passes through the vertex. That line of symmetry, that vertical line that divides it into two symmetrical halves, always passes through the vertex. Here's the part where students mess up on when I talk about the axis of symmetry. If it's a vertical line and you have to give the axis of symmetry, it's a line. So that means you have to write it as an equation. It's not just a number. It's not just a number, it's going to be an equation. Does anybody remember how equations for vertical lines go? Back from when we talked about linear relationships last year? What's the same of all the points that are on a vertical line? What do those points have in common?
Just
They have the same x value, don't they? Every point on that line has the same x value. So what's the equation going to be?
0.
No. No. X equals whatever number every point has the same. So it's not always going to be 0 though. It doesn't have to be 0. So it is written as an equation, not just as a number. And so we're just gonna put right here, we're gonna say x is equal to a number, and we're gonna figure out what that number is gonna be. Okay, so since it always passes through the vertex, and all the points on that axis of symmetry have the same x value, and I say to you that the equation of the axis of symmetry is x equals a number, what do you suppose that, where do you suppose we could get that number from? Of the order pair for the vertex. The vertex is on that line of symmetry. That vertex has an x value. So remember, every point on that line of symmetry has the same x value, so we should be able to steal that x value right from the vertex and say, oh, that's the number we're going to set x equal to. So let's look at 2. We're moving on to the next page. So flip the page in your book, and we're going to do 2a and 2b, where it says find the axis of symmetry.
The check it out or the example?
Yep, check it out. Let's go right to the check it out. Find the axis of symmetry of each parabola. What's the vertex of that parabola?
0, 4.
Negative 4?
Or negative
No.
4, 0.
Negative 3. 3, 0.
Negative
So -3, 0 is the vertex for the graph for 2a. Well, if, remember, the line of symmetry is going to go through that vertex, so what's the equation of the axis of symmetry going to be? X equals -3. A vertical line could be drawn through that vertex that would divide the parabola into symmetric halves, and that vertical line's equation would be x equals -3. Okay, so that's one of the ways to find it. Okay, now we're gonna look at another way to find it. In other words, if you look at 2b, can you tell what the vertex is for sure?
No.
No, that one's kind of sketchy. It looks like it might be ordered pair 1,
4.5.
4.5. It might be, but we don't know for sure. So instead of us trying to guess what the vertex actually is in that case, because it's not really sure, here's what we can do instead. We can find the zeros, because those would be the places where it's crossing the x-axis, and halfway between should be the vertex, halfway between, because that's where it makes its turn, and then it starts doing the same behavior. So this one, what are the zeros of that parabola? 2b. What are the zeros?
0 or 2, -2.
-2 is one of them,
And
4.
and +4. Everybody see those? Where we're getting those from the graph?
what do we put in
The zeros are -2 and +4. We're going to add those to zeros, and what would get us halfway between them? Divided by 2. So we'll divide by 2. Okay, so first thing we're going to do is add those together. What's -2 plus 4? 2.
Oh, -2, just kidding.
And so now we're going to take that sum, divide it by 2, so we can find halfway between, and it would be 1. So now we found halfway between the zeros, which should be where the vertex is, which should, remember, the vertex is on the line of symmetry. So what's our axis of symmetry going to be? 1. It's going to be not 1, but
X.
it's an equation. X equals 1. This is where students always go wrong. It's a line. It's not just a number. It's a line. So x equals 1. Okay, so sometimes we can just look at the graph and we can tell very clearly what the vertex is, and we can pick up the x value from it and say, okay, I'm going with this. Now, when we go back and look at that, and we remember how we said we thought the vertex was at about 1, 4.5? We said right away we thought the x value of the vertex was 1. We verified it by doing it mathematically also. Okay. The next thing we're going to be doing is example 3, where we're finding the axis of symmetry by using a formula. So in other words, we don't have a graph. We don't have a graph to look at. So how are we going to find that axis of symmetry without the graph? So it says, I'm telling you right here, we're going to determine the a and the b value of the function. Well, before you can determine the a and the b value of a function, what form does it have to be in?
Standard.
It has to be in standard form. So if your equation's in standard form, you can go right to identifying a and b. If it isn't, you got to get it in standard form first. Okay? So, and then we're going to use this little formula. See, it starts with x equals, so there's part of our equation. And by taking a negative b divided by 2a, that's going to give us that number that x is equal to. So let's look at our number 3, our equation here. Y equals 2x squared plus x plus 3. Is that in standard form?
Mm-hmm.
Okay, it's in standard form. Y is alone. X squares are first, then x's, and then the constant. So what's our a value? 2. What's our b value? 1. So now we will put that into our little formula. X equals negative. That negative sign is separate. Okay, what's the b value? 1. And 2 times 2. 2a is downstairs. 2 times 2. So x equals negative 1/4. Now, would that have been, if they had shown us the graph, would that have been an easy value to pick out? No, that wouldn't have been an easy value to pick out from a vertex, would it? So sometimes, especially when the x value of the vertex is not an integer, it's a fraction or a decimal, then this formula gives us the exact accurate answer.
So if, like, on the one that we just did, so number 3, if that one would have a graph, could we just do what we did with 2B, like divide by the 2?
If you can know what the zeros are, but this one, did we know what the zeros were? Yeah, this one we didn't have a graph, we didn't know what the zeros were, we don't have any information, we just have the equation. So when we just have the equation, this is the method we're going to need to use. We're going to need to use this little formula. So what are we going to call this? What is this again? No, what is this?
Axis of symmetry.
Axis of symmetry. Okay. So when we identify the zeros, those don't get written as equations. We just say, okay, here's what the zero is. It's 3 and it's -1. If we're talking about the axis of symmetry, then we have to talk about it as an equation. X equals, and what's that value, what's that number, where the axis of symmetry will go through, and you get the x value from it.